All right, so this is a key to topic 19, part C, and that's worksheet 2. And so in number 1, you're given two functions, f of x, which is equal to negative 2x plus 5, and g of x, which is 3x plus 1. Again, notice those are two linear functions. All right, so we have two linear functions. And then in 1a, you want to find the f plus g at x. So in 1a, um, you want to find f plus g at x. So again, by definition, this means f of x plus g of x. And so f of x is negative 2x plus 5. I don't need parentheses here since I'm adding those. And then g of x is 3x plus 1. And so when I combine like terms, negative 2x plus 3x is x, and then 5 and 1 is 6. So therefore, f plus g at x is x plus 6. All right, now, so that's your new function. So that x plus 6 goes here. And then you want to find the domain of this. All right, so in part B, the domain of f plus g at x. So remember that's a polynomial function. So the domain of a polynomial function is all real numbers. In fact, you know it's a linear function. So if you were to graph this function, it would be a line, and it would be positive slope. So the domain will equal all real numbers, negative infinity to infinity. All right, so negative infinity to infinity. Then you're going to subtract the two functions. So in C, now you're subtracting g minus f at x. So remember, subtraction, you're going to need parentheses at some point. So I get g of x minus f of x. And so g of x is 3x plus 1. But you are subtracting f of x. So you're subtracting all these terms. You got to put that in parentheses, negative 2x plus 5. Getting rid of the parentheses, I have 3x plus 1. The opposite of a negative 2x is a positive 2x. The opposite of a positive 5 is a negative 5. Combining like terms, 3x and 2x is 5x. 1 and negative 5 is a negative 4. So therefore, g minus f at x is also a linear function. All right, so we have this line. It's a positive slope. 5 is positive. So g minus f at x is 5x minus 4. Now remember, we had a discussion, so that's a polynomial function. The domain of all polynomial functions is all real numbers. You could have also noticed, hey, this is a linear function, so the graph is a line, and the slope is positive, so it rises. So the domain is all real numbers. So all real numbers, negative infinity to infinity. Now we're going to multiply f and g together. So in D, you have f times g at x. So remember, that notation here means f times g. You don't have to always see that little closed dot there, so keep that in mind. So by definition, this means f of x times g of x. All right, and so remember, when multiplication, you need those parentheses as you go through this. So we're going to get, let's see, so f of x is, negative 2x plus 5. G of x is 3x plus 1. Okay, notice the parentheses, and so I'm multiplying these two binomials. So a negative 2x times a positive 3x is a negative 6x squared. The outer is a negative 2x. The inner is a positive 15x. When I add them up, I get 13x. And then 5 times 1 is 5. All right, so I have this quadratic function. So f times g at x is this quadratic function. All right, so if I were to graph this, it would be a parabola, and we know that all polynomial functions, the domain, so let's see, that's f. So I'm kind of missing some letter here. So this was A, this was B, this was G, C rather. Okay, D was this. Okay, this is E, sorry. So E I didn't write down, but I just put it here. Okay, and then f, remember, since this is a polynomial function, the domain is all real numbers, negative infinity to infinity. It's a polynomial function. Okay, remember it's a quadratic function. It's a parabola. In fact, this one's going to open down like this. And so you go from negative infinity to infinity. All right, so f, okay, so this one was, let me go ahead and write this down. So e, the answer is negative 6x squared plus 13x plus 5, and the domain is all real numbers, a polynomial function. Now we're dividing, so remember you have the rational function this time. So remember in the previous lesson we talked about rational functions, finding the domain. So when we do g, we have f divided by g at x. So by definition, this means f of x divided by g of x. So f of x, remember, is negative 2x plus 5, so it goes in the numerator. G of x is 3x plus 1. And if you can reduce, you go ahead and reduce. I cannot reduce here. So remember, though, we have this rational function now. And so we cannot divide by 0. So I got to figure out what that restriction is. So we need to find the restriction. So we're going to set this denominator equal to 0. And so when I solve for x, I get 3x equal negative 1. And so x is negative 1/3. So my restriction, the restriction is that x cannot equal negative 1/3. So to find the domain, you put negative 1/3 in the number line and you cross it out because you cannot use it. So notice I'm going to have two intervals. So I'm going from negative infinity to negative 1/3 union, and then negative 1/3 to infinity. Again, those are parentheses here, not brackets around negative 1/3. You cannot use negative 1/3. That's not in the domain. All right. So in letter G, the answer is going to be here. It's going to be negative 2x plus 5 divided by 3x plus 1. And then the domain will be negative infinity to negative 1/3 union, and then negative 1/3 to infinity. All right. Okay, now number 2, you're dealing with a linear and a quadratic. So let's do that one. So number 2, we have f of x is 3 minus 4x, and then g of x is x squared minus 49. All right, so in 2a, you want to find f minus g at x. All right, so by definition, this means f of x minus g of x. And so notice I'm subtraction, so I have to put this function in parentheses. So f of x is this linear function. G of x is this quadratic function. Okay, and so when I get rid of the parentheses, I'm going to add the opposite of each of those terms. So I get 3 minus 4x. The opposite of x squared is a negative x squared. The opposite of negative 49 is a positive 49. And let's go ahead and put that in descending order. So I got negative x squared minus 4x, 3, and a positive 49 is a positive 52. All right, so for that one, we're going to have negative x squared minus 4x plus 52. Now in letter B, you want to find f divided by g at x. So so f of x, so that, remember, that means f of x divided by g of x. So f of x is 3 minus 4x, and g of x is x squared minus 49. Now remember, you want to reduce if possible. Now I can factor this, but it's not going to help me. 3 minus 4x divided by x minus 7 times x plus 7. So you see, it's not going to help. All right. So I could just leave the answer as this right here. All right. So I get 3 minus 4x divided by x squared minus 49. Or you could have said 3 minus 4x and divided by, and then just go ahead and factor this. You've got an x minus 7 times x plus 7. Okay, but now you want to find the domain of this, though. All right, so that's where that denominator comes in. So if you factored it, it may help some of you if you had factored it. So when you do C, remember, in C, you have to find the restriction. Okay, and so I'm going to set each of these factors equal to 0 in the denominator because we can't divide by 0. Now some of you can look at this part here and determine what x is. So 7 times itself is 49. 49 minus 49 is 0. And so it's negative 7 times itself is 49, and 49 minus 49 is 0. Or you could just use these. So x minus 7 equals 0, x plus 7 equals 0, and then you solve for x. And in both cases, you get the same thing as if you had used this one. And so my restrictions is that x cannot equal 7 or negative 7. So you put that in the number line, negative 7, make sure you put them in order, and then cross them out because you cannot use those. That's not part of the domain. And notice you're going to end up with 3 intervals. So you go from negative infinity to negative 7, union negative 7 to 7, union 7 to infinity. Okay? And so that is it. I'm going to write the answer down. Negative 7 to negative infinity to negative 7, union negative 7 to 7, union, and then 7 to infinity. Okay, notice the parentheses because he cannot use 7 and negative 7, so that's why you see parentheses. All right, so that is the key to topic 19, part C, and this is worksheet 2.